Hey guys, this is me Rachit Jain, and today I am with a legendary coder that I admire a lot. And I don't know if you know his real name, but he is most popularly known as ffao on Codeforces, and the real name is Fernando. Hi Fernando,
Hey,
how are you doing?
how's everyone? I'm good. How are you?
What's the time over there?
It's 12:30 a.m.
Uh, I really thank you for cooperating and staying awake at that time. And I will just quickly begin off and ask a set of questions that I have in mind, followed by some questions, two or three maybe, that students want to know from you. Okay. So,
Yeah,
guys, just to tell you this, this is more focused on the programming journey of FFAO. How do we pronounce it, first of all? FAO?
I say it as four letters.
You say it as?
Four letters. FFAO.
FFAO. So yeah, this is the journey of FFAO, and I will be asking some basic questions, and let's start. Okay. So, so I have this graph over here of FFAO. As you can see, he's really great. Now he is at orange, but yeah, he has not been doing programming for a while, and now he's working in Microsoft. But yeah, let's ask the questions. So, can you quickly tell us a bit information about your educational background?
Yeah, so I have a bachelor from a Brazilian university. It's Instituto Tecnológico de Aeronáutica, ITA. I majored in computer engineering.
Uh-huh. So, like that was for 4 years,
Yeah, 5 years.
5 years. Awesome. So you are a computer graduate.
Yes, computer engineering.
Awesome. And so, what is the culture over there? Everyone like does really great coding over there, or what is the culture like? Did you get some help from the seniors?
Yeah, the seniors really helped me a lot. In my university, usually the seniors give a course to newer students when they come in, and I hadn't heard about competitive programming at all. I didn't
Uh-huh.
even know it existed, and the
Oh,
seniors they taught me like all the basic stuff, Dijkstra, dynamic programming, knapsack. They really helped me, and then I joined one of the teams, and the people on my team also really helped me. They
uh-huh.
were really patient with me because they knew a lot more than I did, and I asked a lot of dumb questions, and they tried to answer all the questions as best as they could.
I see. Nice. So, yeah. So the next question is, when did you actually start programming?
Yeah, I actually started programming when I was in sixth grade, Brazilian sixth grade, which is about 13 years old.
Uh-huh.
And I started because I played a lot of games and I wanted to know how to code my own game.
Uh-huh.
I guess a lot of kids start programming that way.
Uh-huh.
But I realized it wasn't that easy to make games. I started with very simple stuff, like you typed a number and it told you if the number is even or not. And
Okay.
eventually it grew to more difficult stuff, like doing a command line tic-tac-toe game and that kind of
Uh-huh.
stuff.
Mm-hmm.
I really struggled with programming at the beginning. It wasn't like instant. I was 13 years old. I read a tutorial and I knew how it worked. I really had to spend some time understanding how if and while and everything else worked.
Yeah,
And
but
then
at
yeah,
13, but at 13 you started all this. That's I think really awesome. At 13, most of us are like just fighting with our moms to let us just go in the rain and enjoy it. We are not that serious. We are just enjoying our childhood. But yeah. So like, did you had fun doing all this in your childhood?
yeah, I did it because I thought it was fun. I wanted to make games because I think they're fun. And when I started programming, I thought programming was fun too. And then I
Yeah.
started programming for programming itself
Yeah.
because I think it's fun.
So what was the first language that you started off with?
It was Python.
Python.
I think it's really simple for beginners. I
That's
liked it.
true. Right. And So when you started off with the development, programming, and all those kind of things, so did you encounter data structures and algorithms at your early part of childhood only? Like maybe in one or next 1 or 2 years, you came and you came to know about, yeah, there are stacks, queues, and all those kind of things, or it was later on in your life?
Oh, it was much later on. I had to solve some problems, but I didn't really know algorithms, so I just did brute force solutions and exponential time
Ah.
backtracking until I got to university and all the seniors taught me about stacks and queues and all the stuff I didn't really know before.
Mhm. That I think that's great. Like if you started off in your university and like I've been admiring you like for a lot of time, and I never knew that you are just a student like me. I used to think like, yeah, man, he has been doing this stuff for years and years, and yeah, he has been having this idea for a very long time. But I think it's great that you picked up so real fast, and I just want to know like what really helped you. So do you think that your journey was like really fast? You picked up things really fast?
Uh, it was a bit fast, but it was also because I put in a lot of time. Like in my first year of vacation at university,
Mhm.
I went to Sphere Online Judge and I solved 200 problems. So
Oh, where?
Sphere Online Judge, Spoj.
Oh, awesome.
Yeah, and I mean it doesn't happen overnight, right? There's a lot of study you have to put in, and if you study a lot, eventually you get it. I think.
Exactly. I think that's true. There is no shortcut. You have to go through the journey.
Yeah,
So you mentioned that in summer vacations you solved over 200 problems. So was there some senior who was guiding you all the way, or you were doing it on your own?
I was just trying to solve them all because I was in the Brazilian Sphere Online Judge, and they had a an archive of all past Brazilian competitions,
Mm-hmm.
and those were the competitions I was trying to study for mostly. So I just thought, no, I'm just going to do all of the problems, or at least the ones I could, because there were some that were harder and I couldn't do them.
Uh-huh. I see. Okay. So another question that I wanted to ask you is, why does background eventually help to succeed in competitive programming? Like I have heard a
Yeah,
lot of programmers saying about this that I asked even ZS Coder about his journey. Like he is also a student, but he's doing really great. I don't know if you know him. I think you must be knowing him. You have heard about ZS Coder?
I'm not sure.
Yeah, so he's very much active on Codeforces. So his graph took a real exponential growth recently, and he has been doing great. And he is also like from a maths background, so that's what we want to know. Like, why exactly is math background helping? Because most of people just run away from math.
Yeah, math background helps so much. I can even tell where math ends and programming begins. There are so many things about math that are used in competitive programming. Like geometry problems are almost 100% math.
Yeah.
And then you have function combinatorics is almost 100% math. You're counting stuff.
Hmm.
And you have functions and you have to manipulate expressions, like isolate variables. And yeah, it's all programming and it's all math. And a funny thing is that when I started studying for competitive programming, I started to do better at math too, because both are so related that they're almost the same thing. I mean, at least discrete math, the discrete part of math, like
Uh-huh.
calculus isn't used that much. Maybe for some geometry problems it's useful too. Everything is useful somehow.
And what
Yeah,
about you? Like, you are fascinated with maths like from your childhood? Something?
yeah. I always liked math.
Uh,
Ever since I was a little child, I learning addition. It- I didn't really learn it that fast, but I found it really interesting. So I looked a lot into it and hard math problems. Not that hard, not Olympiad level hard, but what a 6-year-old considers to be hard.
yeah.
And yeah, I always really liked math. I never ran away from it.
Yeah, I think maths is really important because Even when I was studying about dynamic programming, I could somehow relate it to functions in maths and building recurrence relations. So, and I love maths a lot. I love it like really a lot, and the analysis and all those kind of things. So I could relate a lot of things in competitive programming, like for dynamic programming, and then you have matrix exponentiation. So yeah, math comes at useful at various points in the journey of competitive programming. That's what I also believe. And thanks for adding your valuable information on that. So, moving on to the next question. Uh, yeah, so this is one of the concerns that I don't know how I should answer. So, the should students prefer math over computer science for graduation?
Yeah, I don't really think there's one answer for this question. I mean, it depends on what the student's preferences are. Uh, Math and computer programming are different fields, so if you like programming, maybe you should go for computer science.
Mm-hmm.
If you like math, and I know some mathematicians that get programming jobs because they need analytical skills. They need to study a lot of data and do statistics and whatever. But essentially, what I would recommend the students do is that they look at the people who are graduating in each of those fields and look at what they do with their life and see what appeases to you most. Basically, do your research and see where you'd like to go. I can't answer that question for you.
Uh-huh. I see. Okay. Uh, yeah, so this one is my favorite. Can you relate your success in programming to your childhood?
Yeah, definitely. I never ran away from math, so I know a lot of math, and people who do competitive programming need to know math because of the reasons we talked about earlier.
Mm-hmm.
And I also knew a lot about programming. So when I started to study competitive programming, I didn't have to go back and learn what an if is, what a while is, what a for is.
Mm-hmm.
And I it took me some time to learn that when I was a child. But when I started to study competitive programming, I didn't need to do those things anymore.
Uh-huh.
And essentially, it's everything you learn in life you bring with you to competitive programming, like the way of thinking and stuff. And that's why many good competitive programmers started at a very early age. Yeah, like veteran tourists. Yeah.
Yeah. Okay. Moving on. So this is a tough one, and many people want answers to this. How can intermediate coders, maybe expert on Codeforces, they excel and reach the next target? Because I've seen a lot of students, they struggle a lot moving from Div 2 to Div 1, and they are trying really hard, but I don't know, they are not able to move and reach the new height. What's your take on that?
Yeah, sometimes you might think you plateaued because there is a gap between each problem, and when you manage to be able to solve the next problem, then your rating usually shoots up. Even if you look at my graph, I had a almost a straight line for a big time in purple. I think it was
Yeah, yeah, I get
1800. Yeah, and the important thing is to not give up and keep studying and keep doing competitions. And it's very important to there is always this problem you were attacking when the competition ended, like the problem you believe you have the most chances of solving.
Mm-hmm.
But after the competition ends, you should look at this problem and think about how was I thinking about this problem, and then you look at the solution and you see, oh, how could I have thought differently? What maybe I should look at this kind of problem in a different way that allows me to see this that this is a solution faster. And maybe this solution is, you can even generalize it to a broader class of problems. So you shouldn't try to take the solution and apply it only to that specific problem. You should see how the solution applies to possibly other kinds of problems,
Yeah,
and how you should work about identifying those problems when you see them in the future.
yeah.
And keep studying and keep going, and eventually you'll climb.
Yeah, I exactly agree with you on that because up solving is really important. And even if you're failing at solving problems, the most important lesson is how you react to it. And if you are learning from your failures, and if you are making sure that I will solve such problem the next time I see it, I think doing that for a period of time will eventually raise you to the next level.
Mm. I never really cared about my rating going down. I always cared about, have I learned something from this competition? If I have learned something, then I'm happy.
Yeah, I think that's really important because there was one time in my life where I was really too much emotional about my rating. And if I'm giving more time, I would expect it to shoot up, and it was shooting down. And I was like, what is going on? I was getting frustrated. I decided to quit competitive programming, that I'm not meant for this. Like, it's waste of my time. I'm not improving. But yeah, eventually I feel that it's really important if you just keep aside that emotional part and just focus on the learning, because eventually that will make you better.
Yeah, I agree.
Awesome. So these were the questions that I had in my mind, and there are some of the questions that students requested. I will just quickly go through them. So some students want to know how to understand the hard and tough concepts like FFT or centroid decomposition. Like, what's your take on understanding some topics which are really hard?
Yeah, so for this question, I believe that it is not the right question to ask because I was read on Codeforces on like 2013. I don't remember,
Uh,
and
you were read on code
yeah,
forces
somewhere
in
around that.
2015.
2015. Oh,
Yeah.
that was later than I imagined. But anyway, I went to the Google Code Jam finals on 2015 too,
Uh-huh.
and
Nice.
the
Congrats.
Hacker Cup finals. Yeah, thank you. It
That's
was
awesome.
really fun, and and I didn't know FFT in 2015. I didn't know centroid decomposition in 2015.
Ah, I see.
Yeah, I learned about those in it was 2016. Or, I think it was really late, and essentially you don't really need those because 95% of the problems you can solve using dynamic programming and Dijkstra and the really basic stuff, but what matters is how you apply this basic
Mm-hmm.
stuff to the problems. So that's why I said you should focus on doing competitions.
Mm-hmm.
So when a concept comes up, you learn it, and if it comes up a lot, you eventually pick it up. And when I see something that is entirely new, so to actually learn something, I look for a tutorial about someone who really knows the subject.
Mm-hmm.
And sometimes there are a lot of bad ones, so you need to look for a good one.
Mm-hmm.
And I try to do the most basic stuff possible with that technique. And then I try to do some more to expose myself to different ways that problem can be used, that technique can be used, maybe five or six. And then I just forget about it until it comes up
Uh-huh.
naturally again. Because if it's actually important, then it will come up naturally. And if it doesn't come up naturally, then it means it wasn't that important anyway.
Makes sense. So let me know if I got it right. So your point is that instead of focusing on miscellaneous topics like FFT and all those kind of things, students should really focus on the general topics and be a master in that. Invest their time in that, because these are the topics that are frequently occurring in the realm of competitive programming, right?
Yeah, yeah, that's right.
And if you have to study something really new and something that you find really difficult, the best and very important way is that you should find out the good resources, because there are a lot of bad resources as you have mentioned in internet. So you should really go through one or two resources maybe which are really good, like the author of those posts should be really aware of the concept, and then you just try to understand and solve maybe three or five problems.
Yeah, that sounds right.
Awesome, thanks. Okay, and the next question is how to select problems for practice, like ladders in A to OJ, sort problems by tag and number of submissions, which are not that great. Like,
Okay, I think I mentioned this already in my previous answer, but what I usually do is I take problems from past competitions, especially when I'm studying for a certain competition. Like when I started, I was studying for the Brazilian Olympiad in informatics.
yeah.
So I did a lot of past editions of that. And later on, I went to do the ICPC. So I started doing a lot of regionals of ICPC. There are a lot of them online
Mhm.
from all regionals around the world. That's a really good source of problems. And there are also the online competitions like Top Coder and Codeforces that have a lot of good problems too. And I think the interesting part about those is that first of all, you don't know what the topic of the problem is, so it teaches you a lot about how to approach a problem in order to see what's the underlying solution, which is
Mhm.
important. And the second thing is that there will always be one or two problems that you're attacking when the competition ends, and you feel like you are almost able to solve, but not quite. And then you can use your up solving time to focus on those and learn something that is your next step to getting better.
Yeah.
And a fun thing is that I mentioned that I went to the Code Jam finals, and another finalist he came up to me and he asked, "Hey, where do you find problems to practice? I don't know." And then my answer was, "Oh, you tell me because I don't really know." Either." So, yeah, it's a problem people of all levels have. The important thing is just to do something, and
Yeah.
eventually something will be good enough, and you learn something.
Yeah. And I would like to add something to that. I have actually seen that Peter writes blog about the problems and his competitive programming week, and he does talk about a really fun problems. I don't know, they are really interesting for me because I'm not that great as you. You might not find it that challenging, but yeah, for me and I think for other people over here in India, we might find them really like very challenging.
Yeah, he only writes about really hard problems
Yeah.
mostly. Yeah, I find it very interesting.
Uh-huh. Good to know. And so this is the last question, and I won't bother you after that. You can sleep peacefully.
Yeah.
So the last is tackling DP and understanding the states to be defined, and like how this process goes really fast inside the head of great coders.
Okay. Yeah. So I didn't get DP overnight too. I had a lot of problems with DP for years, and especially in Top Coder, they have really hard DP problems, and I struggled a lot with them.
Mm-hmm.
But how I approach DP mostly is that I essentially go. I find that the top-down approach is more intuitive than the bottom-up approach. So what you do is you create a like an exponential solution, a backtracking solution, the most stupid solution you can imagine to the problem. It usually comes to your head in like 30 seconds. It
Yeah.
doesn't need to be anything complicated. And then you put everything you need to for this solution to work in the arguments to the function. Like
Yeah.
you can't use global variables. That's a mistake I see people doing a lot. And if you're really lucky, you see that this function, the arguments you call this function with are not that many different arguments,
Yeah.
and then you can just use memorization, and you basically solve the problem using DP without actually using DP. Because sometimes people see DP states and they think it's something really complicated, but sometimes it's actually the most intuitive arguments you can pass into a brute force solution, and it just works.
Yeah.
And then there are the times in which that doesn't actually work, like you're passing like a very big number to your function, and then you look at the body of the function and you see that you don't actually need everything that you passed. For example, you're only using the sum of the digits in this number, so
Mm.
you can pass in only the sum instead. So
Oh,
this is the a kind of reduction step in which you
yeah.
look at the arguments you have and you realize, oh, hey, maybe I don't need this. Maybe I can use something smaller.
Yeah.
And then this is how optimization works. You get the DP state smaller,
Yeah.
and eventually you get them into something manageable. And that's generally how I approach DP problems. It usually tends to work. Also, a lot of practice, but that goes for everything. A
Yeah.
whole lot of practice because there are many hard DP problems. It's not an easy topic.
Yeah. I think you have summed up perfectly and beautifully about this. And I don't know if you have seen my video, and I am damn sure you must have not. But I had made a video for dynamic programming introduction, and this is exactly what I wanted to highlight in that video.